Welcome to the course on cloud computing. I am Sapna Raghuwanshi, Assistant Professor from R.C. Patel Institute of Technology, Shirpur. This module focuses on storage virtualization implementation, key, fe- key underlying technologies and methods for providing virtual storage to compute system in a VDC environment. This lesson covers the key benefit of storage virtualization and the various layers at which storage virtualization technologies are implemented. Storage virtualization is a process of masking the underlying complexity of physical storage resources and presenting the logical view of these resources to compute system in a VDC environment. So storage virtualization enables creating one or more logical storage on the physical storage resources. This logical or virtual storage appears as physical storage to the compute system. The logical to physical storage mapping is performed by storage virtualization layer. The virtualization layer abstracts the identity of physical storage devices and creates a storage pool by aggregating storage resources from multiple heterogeneous storage arrays. So virtual volumes are created for these storage pools and are assigned to the compute system. Compute system remains unaware of the mapping operation and assesses the virtual volumes as if accessing physical storage attached to them. Thus, virtualization enables adding or removing storage without affecting applications availability. It increases storage utilization by consolidating multiple heterogeneous storage resources and creating storage pools. Storage pools provide flexibility in storage resources allocation to the compute system and increase storage utilization. This considerably reduces investment in new storage resources and thereby lowers the total cost of ownership. Data migration is required during the technology refresh initiatives where newer storage systems replace the legacy storage systems. It may also be required to move data between different storage systems when performance and availability requirements change. Storage virtualization enables non-destructive data migration between storage systems uh, since it masks the complexity of underlying physical storage resources. It also enables support of heterogeneous multi-vendor storage platforms. In a virtual environment, different virtual machines running different applications can exist on a single compute system. This creates a very complex environment as there exist multiple sets of workload and requirements. It can be extremely challenging to manage such an environment in a traditional storage environment. However, by implementing storage virtualization, the complexity in the storage provisioning is removed from the environment. Features such as storage pools, storage tiering, uh, and virtual provisioning are the key advances in storage technologies that provide this simplification. So you will learn about these features later in this module. The virtualization and storage virtualization may be implemented at compute, network, and storage layers. At the compute layer, hypervisor allocates storage space for VMs without exposing the complexity of the physical storage. Block and file level virtualization are network-based virtualization techniques which embed intelligence of virtualizing storage resources at network layer. At storage layer, both virtual provisioning and automated storage tiering simplify the storage management and help to optimize the storage infrastructure. You will learn about each of these concepts later in this module. This lesson covers the various virtual machine storage options that are used to provide storage for virtual machines running on different compute systems, and also covers consideration for provisioning storage to the virtual machines. A virtual machine. Virtual machine is stored as a set of files on the storage devices assigned to the hypervisor. One of the file called virtual disk file represent a virtual disk which is used by a VM to store its data. The virtual disk appears as a local physical disk drive to the virtual machine. The size of the virtual disk file represents the storage space allocated to the virtual disk. Hypervisor may access FC storage device or IP storage devices such as ICSCI and NAS devices. Virtual machines remain unaware of the total storage space available to the hypervisor and the underlying storage technologies. Virtual machine files could be managed by hypervisor's native file system called virtual machine file system, or a network file system, that is NFS, such as NAS file system. These two file systems are discussed in subsequent slides. Virtual Machine File System (VMFS) is a native file system for hypervisor. It is a simple, efficient cluster file system that allows multiple compute systems to read and write to the same storage simultaneously. It provides on-disk locking to ensure that the same virtual machine is not powered on by multiple computer systems at the same time. If a compute system fails on disk, the lock for each virtual machine running on the failed computer system can be released so that virtual machines may be restarted on other computer systems. VMFS volume is used for providing storage space for creating virtual machine file system to store virtual machine files. Hypervisor support logical volume manager for extending VMFS dynamically without disturbing the running VMs across the compute system. There are two ways by which VMFS can be dynamically expanded. The first method allows to expand VMFS dynamically on the volume partition on which it is located. The second method allows to expand the capacity of VMFS volume by adding one or more LUNs to the source VMF volume to create a large one. Virtual machine can store data directly on the LUN in the storage system instead of storing its data in a virtual disk file on the VMFS volume. Storing data in this way is useful when the applications running on the virtual machines are required to know the physical characteristics of the storage device. Raw device mapping provides a mechanism for a virtual machine to have a direct access to a LUN on the physical storage subsystem. It is a special file in a VFMS for VMFS volume that acts as a proxy for the LUN in the storage system. RDM is recommended when there is a large amount of data on the LUN in the storage system and it is not practical to move on to a virtual disk. It is also used when clustering virtual machine with physical machine. In this case, the virtual machine is required to access the LUN which is being accessed by physical machine. Hypervisors support NAS system through The NFS protocol. The NFS protocol enables communication between NFS client and NFS server. Hypervisors come with NFS client software for NFS server access. The NFS file system must be mounted on the compute system in order to allow NFS volumes to provide storage for all VMs. Provisioning of storage to a virtual machine from NFS volumes is similar to provisioning from VMFS volume. NFS volume is managed entirely by the NAS system.